our cycle, and college name Madhuri Engineering College, and our cycle speciality is chainless cycle, suspension, and one more suspension here. That is our main objective. We are here. We designed chainless cycle, and main is foldable. This is foldable cycle. Next slide. See, sir, this is the main objective and challenges. Go ahead. Yes, sir.
And our main objective of our cycle is to make it cost effective and portable. Like we should be able to carry the cycle wherever we go. And here are the specifications as I mentioned. And the frame material is mild steel alloy. And coming to the ergonomics of the cycle, and where the center of gravity of the cycle is there we place the hinge joint for folding, and here you can see the lock for the folding. And the folding, like the front wheel will be folded and it will be attached to the bar.
Can demonstrate.
Yes, sir.
It's a spring loader.
Yes, sir.
We have a spring loader hinge.
Yes, sir.
Yes. This is the folding.
Side
Yeah.
stand and side stand. This is a
Folding.
Why do we do this foldable?
Actually, next slide, please.
What is the purpose?
It is basically for easy transportation. Yes, for easy
We are
transportation.
not doing anything just like that, right?
Yes, like portable as well.
We can carry to hill area. That's all.
One is illegal. Second is when you deliver.
Yeah.
It is an example
While we are traveling, we use like this for this folding.
And also while coming to the parking purposes, instead of like there will be many security constraints while we park, so we can carry it around, and even we can keep it in our home also.
Under the tables, under the bed.
Good one is that. But tell me one thing. Are you saying that this is an innovation? Saying innovation.
Yes, sir.
Is it an innovation?
Yes, sir.
Actually, in market, folding cycles are available, but with the chain, but with only like chain.
Chains.
And the combination is the folding and chain. This is our innovation. The combination. Yes.
Chainless you're saying?
Yes, sir.
But you have something else for the bride. What is it?
We are using bevellian mechanism.
What is it called? There is a term called
Shaft.
Shaft.
Yes. You have two gauges.
Yes, sir. One here and one is back side. And this is shaft and ball. Yes, sir.
My question is this: you just bought it on frequency?
No, sir. Actually, this one we have with the faculty
And all
members.
like our seniors make.
No, we took the help of seniors, faculty members, and we
My question is, no market.
No, sir.
Our
No,
seniors
sir.
were the one who made the chainless bicycle before that. So we used that.
Okay. What do you guys involved in the design of these parts?
So according to like how much.
The toughest thing.
Yes, sir.
Yes.
Okay.
No, sir. We have done a calculation.
Specifications.
Calibrated.
What is this? What is the advantage? Why? Chain pocket I get it just like how much less than 100 rupees.
It's maintenance fees, like maintenance. In terms of maintenance,
What do you think of maintenance?
Chains.
like chains,
They come out of the pocket. So we
Why it should come out of
will be where
due to movement of tire.
There are so many guys.
The chain is not flexible like this. Chain will be falling up while picking up. Like the chain will be falling.
That's what you're saying. That's what you're saying. Yeah. So that is, I say, rare case.
The chain pockets also, it will be, I mean, after usage, it will bent or something, it's a break or sir. So
There is a life to it.
Yes.
Every 2 years, so
Ah.
thing that. So, okay.
speed also sir. I mean, for the chain
Can anyone ride this?
Yes sir.
How do you feel? See this adjustable height?
Yes sir, seat is adjustable.
See the noise? Now why that noise is coming? Anyone?
Actually, while transporting, we had faced some problem.
No.
Look at this peak mismatch of the small gear and big gear.
There is mainly the
Wider than the pedal.
center distance is said. See, it is actually 90 degrees, right? Okay. Drive 90 degrees.
Yes.
So it has to mesh with the 44 angle. The bevel not good. And there is a slip. It is not meshing properly, or the profile of the tooth is not matching. Mating profile. These are all matched profile.
Even we
You know
we have tried for different angles.
Angles, sir.
Before we have kept this near to this place.
It was very hard.
Very hard. Then
So
we have
we have
gone
changed
for
the angle.
slowly we have taken the angle towards.
So for easiness, we have adjusted the angle.
Then we have matched these 2 points. Then we have got this. Locally it's
Shape, that's the shape part that doesn't come into it.
Aspect changes. Hashtag folder, hashtag changes. Yeah, I mean for backlight, sir.
Yes, backlight and
Backlight.
we had a company exclusively producing the line.
Okay.
Stop
LED, yes sir. I actually thought of using LED, but we use dynamo.
mechanical to electrical converter.
Why to waste that energy, sir? Using pass.
But in further you have to we pour it, they cannot break. You can
Yes sir.
What is
Sir, I mean, talking about this material, we have used lightweight mild steel for the lightweight materials.
same two different things is not matching. You are
Steel,
saying
sir.
mild steel and lightweight.
No, mild steel and lightweight, sir. From frame.
Same weight will be there. You know, what is the density of the specific weight of steel and aluminum? What? Units. Don't worry. Even I've seen my team members, they don't understand this unit. They don't say unit. Don't worry. It's 2.2 or something. Grams per cc. Specifically. 8.3. You can understand. Maybe 1 is to 3 and 2.5. You cannot say that. Or you have done anything significantly in the design, construction, tell me I like it.
we have taken
All design.
No, there is nothing except foldable and chainless combination is very rare. And the combination
That is one
is
thing you are saying.
and the
But
mechanical to electrical
what at the
conversion.
expense of what? What is the cost? Because this will be expensive. Right? This is one thing, but this is okay. But this one, I'm telling you, very expensive. Again, someone said maintenance. You said, what is it? I asked. You said, what is the maintenance free? You said, how?
the duration of the life.
There is chain slippage and all. Yes. I tell you, that is maintenance free. Maybe you have to add some grease. You have to add grease for this also. Any friction. It's a material to material contact. What will happen? You get blown out. You have to have a lubricant. That is, they are all mechanical engineering.
We are electrical.
Separately standing.
No, sir.
These two are also chemical.
3, 4.
Yes. We think mechanical.
Good combination. Why electrical engineering is required in this? No, I'm not degrading.
No, sir. I mean, we have, yeah. I mean, we have
We just wanted to make it interdisciplinary team.
I like that.
Because not only in electrical, we want to
And
enjoy other
doing
doing
as I
other.
mentioned, mechanical should know about electrical. And for example, I'm not a lot. I'm
Actually,
a
we are
mechanical.
interested in electric vehicles, so to do
Exactly.
in the job,
That is future.
yes, sir.
Again, only electrical.
We cannot do anything. Yes, sir. Yes.
We need a combination of
Is there, but
And the combination is perfect.
combination. Fine, good. That's all everything else.
Yes, sir.
That's all over. Over. Heavy is over. Yeah. Dynamo, I don't. It's not very available.
Yes,
But I like it. Personally, I like it. It's going to be expensive. Do you have the concept? The price?
Yes, sir, but actually what is already it was there from our seniors, so for us it was easy.
You
Already
just,
it was there.
Yes.
We have done some changes and worked
According to us,
so it was not that much problem.
No,
If we are doing new one, it will be cost.
not how many marks cost.
Yes, sir.
You are going to sell this.
Yes.
That's all my thing.
And
It's not cost. This is a prototype of cost you're saying, right? Prototype.
Yes, sir. If we do it in bulk, it will be reduced.
Oh,
Also.
yes.
yes.
Mass production.
Okay. Where is the camper?
In the
In the portable mechanism, the changes clearly mentioned.
Wisely he's saying chainless. He didn't say the shampoo.
Yes,
He
sir.
removed chain and socket, but he has introduced a very complex mechanism called
Shaft and
Well,
mechanism.
You said we have to move on with the words like
it is, it's there. You have seen a lot of YouTube shaft.
yes, sir.
You
But
have
in
a-
practice,
you have
it is not
You
there.
have seen this. Real cycle we have. Bigger wheel.
Yes. Bearing.
Yes.
Purely mechanical, very good. Ceramic, highly expensive.
Yes.
Who will buy? Only MK Stalin. Those kind of people. Not big shots. Chiranjeevi. Those kind of people will buy. Not common.
Yes.
When you make a product,
Actually, we thought of making it a spiral and worm gate, the gate set. Instead of bevel, we thought of including worm gates.
worm.
Yes, sir.
Worm and worm wheel. It's called.
Yes, sir.
One is the wheel like this. Another one is
And
the
the
worm.
bus.
Yes, sir.
Yes, we thought of doing that, and the height the road allowance would be maybe problem with that case if we use it.
No,
That
okay.
was
You
the
guys
main
know
concern
about-
for us.
Mechanical guys know about gear system. Different kind of gears.
Yes, sir. Like,
1, 2, 3. Now you have spiral, this is
yes,
basic,
yes, sir.
helical, and then worm and wheel.
Bevel.
And then other combinations, having one lot of type of so many.
Yes.
Worm and wheel is for the higher reduction, first of all, and it's a sliding mechanism
Yes, yes,
by which the efficiency, which means input to output. You give 10 HP, you will get only 5.9 HP or 6 HP max. 5.5 HP. I'm saying, example, 55% is efficient. Keep in mind,
Yes.
worm and worm wheel is a sliding mechanism.
yes.
Sliding mechanism means it's a friction. So we use it only for higher reduction. 1:7. Gearbox is the same. 1:70, 1:100, 1:40. We don't go with spark. We don't go with the helper. But we go with step. But one and all is very fast. One single reduction you get it. That's all right. But here it's not right.
Yes.
Okay, but a good thought. Okay, done. That's all done. Instruction.
Yes, sir. Thank you so much, sir.
So chainless, do you agree it's not an innovation?
Yes.
But combination is innovation.
Folding and changes.
He's not leaving it.
Yeah, we should keep strong on this. What we are doing.
Saying this is
Platoon.
foldable again. You get it. It's all available, right? The hinge
Yes, sir.
Yes.
is standard available.
Yes, sir.
That even the complete piece is available. Tube with the tube.
Yes, yes.
Just hide and then weld it, right? My question is, I'm trying to understand, you guys did any design?
Yes, sir. We designed the frame part. Frame. Chassis. Frame.
In this case, we don't call it as chassis.
Frame.
Yes,
Frame.
Frame.
Okay. Complete thing. You did the FEA on this?
Actually, can you see it?
Hey, it's not design
Yes, sir.
verification plan. Your
No,
design
no.
verification plan. Design
CA.
validation. Okay. This is
We mentioned like while fabrication we made few changes in the angles.
That's with thought of, I mean, this is in software.
there is no bottom view.
Yes, sir. We made few changes while fabrication.
You know how the load will act.
Sir?
How the load will act.
Yes.
You don't have a bottom view. Usually, bicycle comes with this diamond shape, right? It comes with this.
Yes.
That is the best design. Okay. Now you remove this.
Yes.
Okay. What will happen when you just ride it and hit it, or you ride over the speed breaker, or hit out the road impact on side of this, you go like this. This is a
If you have again a bottom board,
Again,
again
you have to
should
keep
have
it in
again
again it is
another
a,
one. So for folding, I have done only.
it is more complex.
why do you even talk about this?
Actually, the order
Actually, our first plan is besides the foldable and changes, double suspension is also one thing. And while fixing this gear part, double suspension mechanism stopped working.
Chainless for shop working.
Yes, sir. While to make it work, chainless is stopping working, and we are running out of time.
Pressing like this, this groove is coming out, sir.
Okay, now will it help now? The suspension
No.
will it just okay.
I think we
You
should-
said no because of this problem, like there is a for that the answer is should be like this. Then it's not a thing. You really close to that, and you can have a small like this thing, the same thing. Then you run the
Sir, actually,
It is like this also. If you fold it, it will not. Folding will not. You have to keep other things for it.
if this angle is not fold.
It will stop to sir.
if
We
we
cannot
add
fold.
another beam, then it
No,
will be a problem.
I'm not saying another base.
Also for this support itself.
Okay. I'm saying that probably you can move it. Angle
Yes,
also.
yes, sir.
So that this cantilever will be closer to this. That's a design. That's a little bit with this
If we put more from angle, you are saying that
yeah, so that this goes close to this area. You have this now.
Yes, sir.
So you get a good load. The load content goes
Directly here.
totally, It's a kind of the load gets into the system. Now it is totally here and then here. First, if this is okay, then it will come to here. One of these two is the weakest thing. Okay. Okay, I think. Anything else? You have any questions? Done? DFA, what is that you said? DVP is design validation plan, which is testing, physical product testing. That's called. It's not verification. Verification is this.
Okay.
Yes, sir.
CAE is a very big term. What you guys are doing is FEA.
If we
Under CAE, there are many things. You won't check.
Yes, sir.
FEA is only one portion. That's what we find.
Okay, sir.
Okay.
John, and I am from team carbon company, and these are my friends Gordon and Cholchal. First of all, I'd like to say that it was a great interesting thing to build a circle Like it was the first time I was designing and manufacturing a cycle from base, and we didn't know many other things, the complexities of building a cycle.
Only you three.
Yeah, next other three of us. Yeah, KT University examination.
Okay. 6 people. Okay.
Yes.
Go ahead.
Then we selected a bunch of team objectives. The things you can see here, design a bicycle with less cost. So this cycle costs approximately 4,500 rupees. That is including the design faults that we did. Like the material choosing was, we chose other material at the first time, because and after doing the building and testing, it showed some slight failures. Like our welds here was not that well, so it broke. So we are not able to bring it, and we had to redesign it. And second is ensure easy assembly. So this was built in making it more easier to fix. Like we can remove these two bolts to remove the entire fork system, and we also redesigned the fork to increase the length for our design.
Fork you designed.
No, fork inside this length, right? That we increase the length.
Column.
Yeah, column. We increase the length for that. And the people that we asked about the survey in our DR1, it shows that most of the people are saying that about the slipping of chain. We solved that one too in our innovative department to be said in that. And we have completed the process testing. So unfortunately only there are 3 of us right now.
Okay.
Because and the other 3 of us was also there to doing the project. Next slide. So the objectives that were completed.
Okay.
This was the pictures and
Okay. Now the slip of the chains. Chain slipping.
yeah, chain slipping.
Which slippage? How you avoid it?
However, it's been discussed in the later slides. So we
Okay.
can
Right. Go ahead.
challenges. The most challenges, as we said, were design and structure of the cycle. So this is our second prototype. As you said, the first one had a failure, and the material selection and the innovative ideas. First, we had an innovative idea of combi brake. That's the same thing that we had in bikes. So, and it was a bit of hassle to do. It will be discussed later in the next slides. And punctuality, like we are little not punctual, right? So when we keep a deadline, we must attain it. It was a little problem, but at last we managed to do it. Next, I would like to give the mic to Joel.
Thank you, Joseph. Myself Joel, and I'm a team member of Carbon Mobility. So I'm going to discuss about the vehicle specifications. As we see, this frame was lighter than the entire cycles in the market, and it was easy to carry for us. And it is a high clearance cycle. You can see it's have a ground clearance is more than the usual cycles we see in these markets, and the seat height was also high because the seat post is also in a very different way manufactured. The yellow color we choose for the high visibility in the darker times. So avoid to make a safety product. The frame was not this one actually. It was a second prototype, as Joseph mentioned. And this was the second prototype. We had to face many faults and defects in the first prototype. So we have to make some alterations in these brake adjusters and the seat posts. And overall, the strength and the stability is always under control. It's always under control. And these are always freshly raw materials which are readily available in our markets everywhere. So it's easy to manufacture when you have nothing else. And the suspension we use is a front load suspension which has a 63 mm long travel, so which is used in mountain terrain bikes. We can have the bump test and comfort for is easier for that, and the maneuverability also is great in these cycles. So it's also a model which is always readily available in these markets with the front travel of 63 mm. And that's with the suspensions and brakes. So we had a prototype idea of equalizer brakes. When we use this lever on the left side, we have to adjust the brake levers with the front and the back at simultaneously working, like the active braking system called combi brakes. So it was a prototype idea. We tried to manufacture it, but the cables have to be joined together. So it wasn't successful. We have to change it to the old settings. we have used a power brake system for the front tires for better braking, because the front load will be more than the rear loads, and rim brakes for the front loads will be more. When you apply the brakes, you have to make a stop, you have to push the suspension more, so more inertia you have to stop. That's a basics. In motorcycle dynamics also, we are using brake system in the front because we very strong.
The spelling of brake, you see,
Oh, that brake,
many places it is.
that power brake, and
You are breaking the brake.
okay. Sorry,
So go ahead.
And brake systems, we have many options. We have to apply disc brakes, everything, but the cost will be high. The manufacturing cost will be high as expected. It will be exceeding the limit. So we have to adjust, we have to limit to these systems. And the greater disadvantage is rubber things. It will wear off after 2 months steady use. So that's a disadvantage. And we are trying to improve with many other materials. And that's all. I am moving to other point.
Thank you, Joel. Good afternoon, sir. My name is Gaurav from the Carbon Company. So, when I'm talking about steering, we have, as usual, an adjustable handlebar with comfortable grips, and it's very easy to replace. We have increased the fork travel, so we can, in order to adjust the modifications we have done to it, we have put a piece of pipe, and when we pull it out, it's more easier.
So when you say adjustable, it is vertically.
Yes. We cut a piece of the fork and welded another piece in order to increase the length of the fork. So in that way we can be more aesthetically, economically pleasing. And now talking about the transmission and wheel assembly. Transmission, as usual, we have the transmission at front. And now coming to the back, we have put 2 types of levels for the moving of the flywheel, and we have used a derailleur in order to.
I can understand.
Thank you, sir. Now we have used a derailleur in order to not to prevent the chain from not slipping. Now the chain will not slip.
How this will prevent?
It will balance the tension.
The thing is, it is nothing but you are tensioning the chain.
Yes.
Tensioning is done for avoiding this slippage.
Yes.
And we usually use a idler here, pulley, it could be pulley, belt, and here it is idler, and here sprocket, idler. It's nothing but idler sprocket by which you are doing it, but this derailleur is an expensive thing.
No, sir, this costs us only about 250 to 300 rupees.
What make is this?
It's under all these, because we doesn't need any of the advanced gear system.
Correct, but I am looking at a new bicycle with this design.
Okay. No, if we have to achieve this, we can manufacture a simple system. Because the spring load system is taking the tension.
Usually, for information, this derailleur we are importing. Shimano, Microshift, these are the big name. And these two are imported. Unfortunately. Okay, go ahead. But I understand that.
So we have made it more economically viable for the ordinary cycles, bringing it to the. And we can adjust it. We can remove the derailleur if we want. Right. And we use arrowhead wheel. We manufacture both the rise and it's of the MTB type. Okay. Now the cost estimation, and as my friend also mentioned, it costs about 4,500 rupees, and considering all other factors, miscellaneous factors, costs usually around about 4,980 rupees or 5,000. And as my friend mentioned, earlier we had many plans for the equalizer brakes, and the frame design was totally different. And after we did a couple of tests, we had to change it. And we actually deviated from our original plan, and finally,
That is not, you don't say that it's deviation. That is how design is done. Always, you start with something, you end up with something. Because you are traveling the path and it will guide you. This is not possible, you have to go to this like that. There is nothing like, first time right design. I don't believe in that.
for example, the material chosen, we chose in our initial design we thought of using aluminum alloys, but it was proven too expensive and difficult to weld. We didn't have the devices for the welding in our labs. We use arc welding and we use mild steel. We changed that. And as mentioned, the design of cycle was the process changed and transmissions.
Okay.
That's also.
That's all. You said less weight frame. Yes, sir. How do you say that this weight is less? What is the height of the frame?
About 60.
Frame. Entire cycle weighs about 60%.
The entire frame cycle?
No, the entire cycle weighs 60%.
16. What is the frame weight? Because frame is the main.
Frame was about 8 something.
8 kg. If it is 8 kg, it is heavy.
With the front fork also.
Front fork will be heavy. Yeah. This is different.
No, with the front fork and frame. No, without tires.
Frame doesn't include fork. You are not measured. Because when you said lightweight, I want to know if not frame, you cannot make the cycle lightweight.
No, we had to carry these from our homestays. From the hotels we stayed.
Okay.
And by foot we carried it, but it was not a problem.
That way you said.
Oh, yes.
So daily use, that's what matters.
Okay.
So we traveled about 2 kilometers carrying this frame. It was lightweight because
One hand.
one hand. Yeah, it was very entertaining. Like walking with the cycle, every people are looking. What was this thing? Like every people are carrying tires, seat, handle like that. It was like a thing that was strong.
Okay. You can check the weight and tell me afterwards. Okay. So why do I purchase this?
So the thing that we are purchasing, as we know, the motto that Indian markets are taking, make in India. So we are trying to compete with the Chinese market, which has many of the low quality products, and we are also trying to manufacture things like, as said, the derailleur, which was being imported from China. So as we are studying it, we understood it was a simple two-spring mechanism. And we are also trying to replicate it because we are second year mechanical students, we don't know much about that spring action or working of that and designing materials. So we will try to study and understand the working of that. The other thing is, it was made by us. So it was like supporting a small startup. As we are seeing, many startups are being growing big because people like small ordinary people are supporting us to grow into other big multinational factories.
Okay. I'm done.
Thank you, sir.
Thank you, sir.
Good afternoon, sir. We are from Team Eureka, from Tyagaraja College of Engineering.
Yeah.
So, small introduction about us. We are Team Eureka, found in 2022 under the SAE Futuristic Cycle Design. Our squad is made up of Our squad is made up of various branches from mechanical engineering, electricals and mechatronics. We have divided our team up into 5. One is frames, other is drivetrain, steering and suspension, brakes and wheels and electricals. Our mission is to gradually replace conventional fossil fuel based vehicles with zero emission vehicles for a better future, reducing all the carbon emissions and hoping to have a greener earth. Our vision is to be a pioneer in manufacturing of economic electric vehicles, creating customer delivery and a greener future. So, introducing Miles, our brainchild is Miles. It's a trial bike. So, the reason we choose a trial bike is it is a bike bike which conquers any terrains, from straight roads to downhills and uphills. It has a very versatile and good maneuverability, so that is why we chose our.
You please keep going.
That is why we chose to do a trial ride. Next. So the challenges faced in doing bringing our idea to life was budget. We wanted as to aim having a lower weight vehicle. We had many challenges with the budget and the time. In the given time, we could not bring out our fullest, and the resource availability. The market around our locality did not have all the items we expected to have. And personal limitations are we had our academic stuff parallelly going with the competition works going on.
I guess this challenge is there for all, right?
Yes.
All these things. Not only your team, for all the teams. Okay.
So the lessons learned are we learned that the bicycle should be designed considering all riding conditions, not only just commuting or off-roading cycle. We considered all rider economics and safety as a main issue. The innovation, we attempted an innovation keeping in mind about all the existing problems from the manufacturers and the customer side. The bicycle, we wanted, before coming and placing it here, we wanted to test it in all kinds of terrains to acquire its real performance. And before starting, we always prioritized on the brake test. So coming to the vehicle specification, we have used an 18-inch frame size, and the material is the AISI 4130. And as I told you earlier, this is a trial bike. The user height range is more than 165 cm, and we have used the phthalo blue color. The vehicle weighs around 19.7 kgs with a wheel size of wheel diameter of 29 inches and 2.4 inches width. It is a 7-speed bike with a mechanical disc brake of 160 mm dia, and it has a wheelbase of 1128 mm with a rake angle of 22 degrees. Next.
What is the brake angle?
Caster. So coming to the frame design process and ergonomics. So when the frame is self-manufactured by us. So when we started to design the frame, we had two main concerns. One, in the rule book, we had given the design concern to be that of an average Indian male, and the second is a rider's height. So according to the mountain bikes chart, our rider had a size of L. Then coming to the customer requirements, after a lot of survey, we had a customer requirements of wanting a comfortable ride even in the bumpy regions and an agile ride. Then began our product design development process. First, about the concept generation, we decided on why we had, or what kind of bike we wanted to do and why we wanted to do. Then we ended up, we wanted to do a trail ride. Then about the concept selection, we had to select what part and why we had to use that. We had to brainstorm.
You said trial bike,
Yes, sir.
which means a prototype kind of.
Yes, sir. Then about the concept finalization, the help of scoring and screening concept. The main factors we considered during the scoring and screening concept are the stability in a higher speed, ease of riding in uneven terrains, because it's a trail bikes, we have to bring it downhill and uphill, and the comfortable seating adjustments, better aerodynamics, and lightweight and comfortable ride.
Lightweight. Explain this.
Lightweight, we tried our best to achieve the lightweight vehicle because a heavier vehicle brings less advantage.
What? I didn't know.
We tried to achieve lighter weight vehicles.
What is the weight of the
19.7 kg.
What is the weight of the frame? Frame alone? What is the weight?
Frame alone.
We cannot measure.
Measure.
Okay, fine.
Then coming to the target specifications, so we had 4 to 5 conceptual designs at the beginning. Then we narrowed down it to 3. Then we picked the best out of the 3, which is standing in front of you. Then market position, we had to compare it with the existing cycles like Hero Cycles, A1, Hercules, and BSA. We had to compare it with what and what existed, and we had to bring it near to that. And while designing the concept, we took care of the rider's inseam height for the standover height, and the torso and arm length for the stack and reach. So according to the chart, the ratio of stack and reach for an MTB is 1.44. So then we arranged the dimensions of the frame. Then the standardized values, we had to refer to ISO standards to bring out the standardized values for the frame.
Do you have anybody else to present?
Talking about staying and suspension, we use flat angle bars which gives better maneuverability, and during mountain rides we have to take sharper turn. So we use flat angle bars with little speed, and we use threadless systems. By using if you use thread system, it's very difficult to assemble, and it requires more time to assemble the thread system. So we go on to threadless systems. And fourth we choose is already one. Sir?
Oh, okay. Okay, go ahead.
So the fork we choose is 121 level, and it's adjustable. We can adjust the thickness of the fork based on various scenarios. And we set a cast angle of 22 degree. Higher the cast angle, better the stability, and it also includes the self-centering effect of the bicycles. And trial is 127.2. It's recorded by tire and wheels high.
One question. You said higher the caster angle is a better stability.
Yes, sir.
That's a very generic statement. I disagree with you. So now this 22 degrees you are saying, right?
Yes, sir, 22 degrees.
So 45 is okay?
No, sir. It should be optimum. It should be, both extremes.
What will happen if you like this one?
Yeah.
This is like this, we found this like this. This is what will happen?
Yes. So it will not.
It will work.
Yes. It should be optimum, sir.
Okay.
And talking about suspension, use front suspension, which is
These are all body and fitted, correct?
Yes. And for the rear suspension pivot points, we use software called Linkage X3. They are Linkage X3, sir.
Linkage?
X3.
Software is it?
Yeah.
Why software is required?
Sir, to really find the hot points of the suspension, sir. This I1 and I2. This hot points. So we simulated various scenarios. We imported our design into that software and found the optimum hot point for to mount the rear suspension.
See, what you need for that is how much is the compression required for a given weight of the vehicle as well as rider.
Yes, sir.
Okay, and so you can define with specific compression. But why software? I am wondering why software is. We are becoming very addicted to the software. You know what is FEA?
Yes, sir.
You just give some notes and we say it's okay. Actually, we have become addicted to that. I would say dependency. You know what? Honestly, I was from a machine tool background. I used to calculate critical designs myself. No software on machine. Very complex boards in machines, metal cutting machines. We have nothing like that. We have very simple calculation. No, I'm just saying the world is going towards. I'm not telling you, everyone. Even FEA, I'm seeing that because we are becoming very lazy. We stop thinking. Google, everything now the latest one is ChatGPT. Yes. One example I tell you, I asked my son, he was studying probably 6, 7, I don't remember exactly. We studied this matrices, right? I don't know which class, math. Matrices, differentiation, integration. I asked him, because I won't ask, when I was studying, I didn't get an answer. I know the answer now, okay, that's it. I asked myself, please ask your teacher where it is used, what for we are studying this matrices in an actual term, physical world. You know what the teacher said? Go on, refer Google. He came and told me. This is where, I mean, you know, the teaching of it goes like that. So I was wondering, this suspension, you are referring to, but anyway, tools will do it. I'm saying, and this is my frustration. Not only you, I'm seeing 4 into 5,900. You stop calculating. You have gone to that level. Okay, you said hard points. What is hard points?
Hard points. This two hard points and
So you
where we
have
mount
those two, the distance between those two.
Hard points is the points where we get the maximum compression and tension on the spring. The spring will be efficiently.
Oh, you are saying that the full, the compression, the maximum compression goes and hits, becomes flat. Is that what you are saying?
No, sir. The points where the shock gets utilized. The load on the shock gets utilized.
where the points
That's
are the
what I mentioned. What is the load coming? How much travel, which is compression required? While I used to design spring, it's a helical compression spring. This is a spec of the spring. I used to design a spring. I used 5 parameters. Pre-pitch, pre-length, number of turns, diameter of coil,
active coils.
So in our cycle we have used mechanical disc brakes. The size of 160 mm disc in front and the rear. We have also manufactured the rear caliper mounting.
Why caliper brake?
Sir?
Why caliper brake?
Why caliper brakes? Sir, we are using an MTV. So if we are going to ride this bike in a different terrain, we need precise braking. So in that terrain, we cannot use rim brakes. If there might be debris that can get stuck along the rims, and we will not be getting the highest braking efficiency. So we have used a disc brake. First, we thought of doing hydraulic brakes. Due to the cost effects, we are.
Hydraulic brake?
Yes.
You guys are thinking very. Okay. You said the other brakes. What are the other brakes used?
Rim brakes, coaster brakes.
Bicycle.
In?
In bicycle, you said this is this brake.
Yes.
What are the other brakes used?
Rim brakes, sir. Rim.
Rim?
Yes.
Rim brake.
We call it
Linear
brakes.
brakes. Linear brakes.
So, no, my question is, we went for this brakes. These two brakes were used on rims. Rim surface, okay. In what way it is efficient, I'm saying? Why you are?
So the braking efficiency of this brakes are
What
higher
is
than-
braking efficiency?
So,
Okay, I'll give you
Stopping
braking distance.
The minimum is stopping distance.
It's called braking distance. When you apply a brake, it will not stop there at that point. It will go travel, stops. So the moment you apply from there to this distance, there it stops to 0. That's a braking distance. That's what you say. Okay. What is the how this is efficient and this is not efficient? Rim brakes is not efficient. Okay. Yeah. Not
the stopping distance is more for rim brakes.
how much?
Each will stop near the simple point.
I am asking data. And I think that
So I'm not finding it.
okay. No, approximately. Okay, this brake, what is the braking distance? Approximately. All are mechanical or?
So it's around 4 meters. Stopping distance for the rim brakes we calculated is around 4 meters.
4 meters.
For length of 50 meter traveling at a speed of around 25 km per hour.
So, actually, when you talk about braking distance, you have to ask first speed. If you start at 1 km per hour, you will stop there itself, right? We talk about 25 km per hour. That's a maximum speed. Usually we consider. At that speed, when you apply a brake, how fast, how much distance it travels and stops to 0. That is the braking distance. Okay? See, your point is valid, but the next level of question we should take. That's what I am asking. So, how mechanical engineers?
Mechanical.
Okay, you work
Mechatronics.
mechatronics.
Mechanics.
Two mechatronics. Okay, please go ahead.
For the transmission system, we have used a 7 cross speed, and with a rear free wheel of each sizes from 28, 24, 22, 20, 18, 16 and 14, and the front chain ring of size 40 to 43 with a pitch of half inch, and the center distance, the distance between the bottom bracket and the rear wheel is 410 mm, and the if we use a modular crank arm, we can vary the height of the crank arm from 125 to 170 mm. And the wheel size is 29 inch, cross 2.4 inch width, and the 36 spokes and the 3 cross pattern arrangement.
One for aluminum alloy rims. Why? They are thinking very costly. No problem. That is your design. I'm asking the question. What is the intent for which I want for alloy ring? We call double wall alloy ring. DWAR. So yes.
We try to reduce the overall weight of the cycles, so
and it looks nice, like you see the single wall, you cannot compare posters. Okay.
coming to the SAEISS analysis, so I think frame is the backbone of the cycle, so it is very important for its design to be safe. So the frame was analyzed for a static condition and a frontal impact load. So talking about the static conditions, we assume the rider weight to be 80 kgs. So the total force is 800 newtons. On the pedal, there is 30% of the force acting. On the handlebar, there is 25% of the force acting, and on the seat tube, there is the rest of the 45% acting. So by calculating those, we have kept the dropouts and the head tube as fixed supports, and using the answers, we ran an analysis, and from that we got maximum stress condition to be 102 megapascal. So as I mentioned earlier, this is AISI 4130, and its ultimate tensile strength is 560 megapascal. So as the maximum stress is lesser than 560 megapascal, we decided our design is safe. Then coming to the frontal impact conditions, we assume this wall, and the cycle is traveling at the speed of 15 kilometers per hour. Assuming the cycle is going to have a head-on collision, we have the rear part of the frame as the fixed, and calculating the foundation stiffness, we arrived at it to be 0.73. Using answers again, we ran the analysis, and we got the maximum stress of frontal impact to be 138.81 megapascal, which is again lesser than the ultimate tensile strength, finalizing that our design is safe.
You are not mentioning about the factor of safety.
Yes, sir. Factor of safety, we have calculated it.
Very simple.
15, sir.
560 divided by 4.
Yes, sir.
It is very high. This 3.5.
15, yes, sir.
That one. 560 by 130 is very high.
Yes, sir.
3. No, why you want to have so much factor of safety?
We've taken the worst conditions, sir. For that, for the materials we have chosen, it comes to be high values.
Okay. Okay, go ahead.
So it's about the suspension and the brakes. So, sir, if you take in case of crankshaft method, so first of all, we are considering average Indian male of 80 kg who will be sitting at the seat. So when he is sitting, the entire cycle will be taking off 800 Newton. So in that situation, the front that is front suspension will be exceeding about 35% of weight, and 45% will be the weight is here, and another 15% will be taken place in the pedal. So we will be calculating this 35 to 45% in this by using the crankshaft method. So first of all, taking the of 16 steps, that is in each steps 1 second will be taking place. So we can be taking in each steps how much amount of travel is going to be. So After it's into the tension, we will be taking deformation, stress and strain. Likewise, the rear suspensions will also be in this. It's about to calculate the rear suspension. The speed of the cycle should be equal. That is 25 km per hour. The cycle will be traveled. So after it applies the brake, how much amount of suspension is going to travel?
What was how much it was compressing at 25 km per hour?
The maximum travel is around 80 mm, sir.
Ideal condition.
Yes, sir, ideal condition. For traveling of 25 km per hour, we reached a basis of around we have taken it for various temperatures. For each temperature, the compression load acted on the spring is around 55 mm, 45 mm, and 30 mm. That kind of things.
Yes, sir, 80 mm.
Yes, sir.
This is the cost and weight analysis. These Falcon, Nimbus and Miles are different cycles we have manufactured. Falcon in the year 2021 and Nimbus in the year 2023. There is a significant increase in cost and weight from Falcon to Nimbus. This is because Falcon was a single speed cycle, but Nimbus was a multi-speed cycle and by 2024, this is the Miles. The cost has reduced slightly, even though it is a multi-speed and rear suspension cycle. We try to reduce the cost and weight. And this is the project plan we have made before we started our works, but there were slight
You
deviations.
finished within the plan. That's what it shows.
No, so there are slight deviations.
Green is the plan. I took it on now.
Orange is the actual. You can see that the purchase of selected components took more time than we planned because the availability of components in the market
Your sourcing person is inefficient. Who is sourcing person? Since
We are not sourcing as a single person. We do it by subsystems.
Okay, then the team is inefficient.
I'd rather say the machining person, we give it for machining, sir. So they are more inefficient. They need more
Machining?
time. Yes,
Oh,
sir.
you're not bought it.
Yes, sir. So there are mounts and the frames, there are few to be machined.
and also we were able to complete the assembly of our bicycle before the predicted time. So because we made the design to be easy for us to assemble. And this is the design failure mode and effect analysis for our vehicle. This was performed to check whether our cycle functions properly and satisfies the user needs. So in the we calculated the risk priority number subsystem wise, and for frames the risk priority number maximum was 175 for the welding defect. So to mitigate this effect, we used proper welding procedures, and the fixtures were also implemented by building the rear suspension mounts. And in steering and suspension, the maximum risk priority number was 192, and this was for like improper mounting of the swing arm. And to mitigate this, we used proper clamping bolts and made good interference fit. And in right train, maximum RPM was for 160 for gearing that leads to failure of power transmission, and this was mitigated by regular inspection. And in brakes, it was 224 for gearing of brake pads. So we used high quality brake pads, and we made regular inspections. And when damaged, we should be replacing it properly. And in wheels, our maximum RPM was for 243 for the puncture of tires, and this can be reduced by riding on good road conditions and checking for proper tire pressure.
RPM.
Yes.
What's that?
This priority.
How will you arrive at that?
So it is the multiplication of detection, occurrence and severity.
The design validation plan for our cycle. We have identified what are the parts we are going to validate and how we are going to test them, and if we test them, how many attempts we are going to give them for testing, and we have concluded 20 marks.
How?
So that for each subsystem there were some parts we identified. So for example, in brakes we could check for the brake lines if they are proper during the brake test. We conducted a brake test and there were attempts, and after 2 attempts if there were any problem with what we did, and some other subsystem, for example in steering, we check for any cracks or anything in the headsets. So similarly for other subsystems we did the test. And for drivetrain we conducted the endurance test, continuously riding the bicycle for 30 minutes at an average speed, and if there are any failures.
Okay. The innovation what we did is model the crank, which means we can adjust the length of the crank arms. By adjusting the length of this, the length can vary from 120 to 175 mm. By adjusting the crank arm length, we can effectively use the pedaling. We can increase the pedaling efficiency. For example, when we go uphills, we need more torque, so that we set the crank arm length to maximum level, so that we can gain more torque. And while during downhill, we need more number of revolutions in crank arm. We set the crank arm length to lower level, which means 120 mm. This is our innovation.
Show me how
Sir, here's a bolt and this part axis on that. By rotating this bolt, here we have threaded portion here, sir. By rotating this, the length of the crank arm will vary.
understood. Screw nut.
Yeah.
Yes. And you are guiding it right.
Yes.
So with as future enhancements, we can change this material into aluminum and use PMCs and like Arduino board to make it
Adjusted automatically. So
we
we planning to integrate electricals to adjust automatically.
battery motor.
Then, which means you need a motor.
Yes.
Exclusive for this.
Small servo.
It's not a motor, it's a gear. You have the reduced RPM, but this RPM is rotate very slow RPM. Okay. Next.
This is another innovation we did in electronics parts. It is a dashboard basically. It has 2 screens. The first screen will be the rider's information, like his weight, height, age, and gender, and we will also be getting wheel radius from them. And at the next screen of the dashboard, we will be having, we mounted it and we showed in the innovation process.
You already shown. Yes, innovation. Okay, go ahead.
So, after entering the details of the rider, it will be, if we press the center button, it will go to the next screen. In the next screen, we will be displaying some dynamic information like speed, RPM, trip time and trip distance, plus calories burned. So, the main...
Calories mentioning.
Yeah.
How much calorie we spent for this particular RPM? Is it that way? I mean, particular screen? You are mentioning that way?
Yes, sir. With the help of RPM, we are
calculating that. Calculating the and you mentioned it. Or it is you have a sensor.
Yes, sir. We have a sensor. Hall sensor is a.
Hall sensor.
We have it here, sir. It will be mounted in the fork, and 2 magnets are mounted in the reflector, sir. So it will count the revolutions and. And the innovation in this is like customizable. Every rider and bike, we can customize it according to every rider and bike. And this design is also portable, so we can fix it in whichever bike we want.
This is there already in